This presentation will describe a compact, low-cost, high-efficiency RF source that we're developing for the U.S. Navy. It's a magnetron that's frequency and phase locked using low-cost, high-performance, fast varactor diodes. Calabazas Creek was founded in 1994, and we've been developing high-technology RF sources and components for uses in fusion power, high-energy physics, and defense applications for over 25 years. We have won a 2011 R&D 100 award for our technology related to advanced cathodes. We have patents, 19 in the US and 2 in Europe. And we have more than 200 years of RF source and component design experience using the most advanced 3D surface field integral and design tools. We also have access to clean rooms, brazed furnaces, bakeout stations, and high power test facilities. In the past, we've collaborated with 6 universities, 5 national laboratories, and have earned more than $15 million in transition revenue. This program is addressing a need that the Navy has for a novel magnetron source generating high CW power at S-band. The requirement is to be compact, efficient, and affordable. The source must be capable of fast tuning over a narrow band with a locked frequency response sufficient to support data transmission. Foreseen applications include advanced radar illuminators, radio beacons, target emulators, and to mimic threats, and simple fire and forget jammers. The basic requirements is to generate at least 5 kilowatts of CW power, operating at 2.45 gigahertz with fast tuning over 5 megahertz, and to support 2 megabytes per second of data transmission using simple frequency shift tuning, and it also must be forced air cooled. Phase lock magnetrons have been around for quite a long time, but the existing technology requires circulators, which, depending on the frequency, can be very large and heavy. The circled item in the photograph is a circulator at L-band, 1.3 gigahertz, and you can see how large and cumbersome that would be for including into a mobile device. So the challenge is to achieve phase locking and frequency tuning without the use of a circulator. We believe this technology will be useful for the Army and Air Force in addition to the Navy. The baseline performance improvements we're looking for is to reduce the size by 70% and reduce the weight by 60%. Our approach to fast tuning magnetrons is to use varactor diodes to modify the capacitance of one or more magnetron cavities. By modifying the capacitance, you can shift the frequency of the cavity. It's basically an LC circuit. So the graphic shows where we have injected the varactor diodes or coupled 2 varactor diode arrays into 2 cavities of a magnetron. The specifications we're trying to achieve is a bandwidth that exceeds 5 megahertz, which we have achieved in simulations. The feedback control circuitry we're using was previously demonstrated, actually used in a laser system developed by SLAC National Accelerator Laboratory, which is a partner in our program. So the key innovation we have is to use varactor diodes to control the frequency and phase of magnetrons. So our current status, the slide says we're in the base program of the base year of the phase 2 program, but we're actually now in the option 1 phase of the program. The base was completed last December. We are in process of modifying a commercial magnetron to incorporate the varactor coupling. We've assembled some of the equipment for the initial test, and we're building the varactor diode array, currently building that in the option program. We've also initiated procurement of a fast programmable gate array for the benchtop control system, and we're actively developing the control software. So the bottom photograph shows the commercial magnetron that we're currently modifying, and the photograph on the right shows the amplifier circuitry we're using to test the functionality. There are a number of advantages and benefits using a magnetron. First, magnetron efficiencies are quite high, exceeding 80%. So this will reduce the size and weight of the power supply. Magnetrons are also inexpensive compared to other potential RF sources, including solid state and traveling wave tubes or klystrons. The frequency and phase control without the circulator will reduce the system size by at least 60%. And the fast tuning bandwidth of 5 megahertz will be sufficient for 2 megabits per second data transmission rate with simple frequency shift keying. Also, the existing and proven feedback control system will reduce the risk. So what we're doing, if we're successful in integrating these features, is it will provide a new RF source with low size, weight, power, and cost for mobile and expendable RF applications. It will also provide enabling technology for potentially new applications. And this technology can, of course, be extended to other frequencies and power levels. So the goals of our program is to develop a magnetron source with frequency and phase control and a ruggedized package for RF source testing. We will deliver a final system to the Navy in the second quarter of FY24. This is only the RF source. In order for this to be useful to the Navy or any potential customer, this RF source must be integrated into a communication system for a UAV or a similar vehicle, or integrated in an agile or compact radar system or expendable target emulator. We don't really see any large commercial applications for this technology. Most commercial applications, such as radar or heating, don't require the precise control of the frequency and phase that we'll provide with this technology. And the output power that we're generating is about 6 kilowatts, which is likely too low for any significant accelerator applications. In order to properly transition this technology, the Navy will need to identify specific programs that require the low SWAP-C RF sources that we're developing. Once they identify an application, it will require a partnership with the prime to integrate our RF source technology into a deployable system. This will likely require additional funding to develop this system. We believe this technology should also be of interest to other agencies, including the Air Force and the Army. If you're aware of someone that might be interested in this technology, we would be very grateful if you would contact us. My phone number is listed on the slide, and our address in San Mateo, California is listed, as well as our website. Reminder that we work with a large number of RF sources, including TWTs, klystrons, inductive output tubes, and power grid tubes. We have experience in single beam, multiple beam, and annular beam vacuum devices. We have designed RF sources from 100 milliwatts to tens of megawatts of delivered power. We specialize in RF loads, waveguide components, electron guns, RF windows, and RF circuits. If you know of anyone that might be interested in our products or our services, we would be very grateful if you have them contact us. Thank you.